Hi everyone, I'm Sandy Chaika from Riverside Brookfield High School just outside Chicago, Illinois, and I'm here to talk to you about lists today. In this video, we will use the pseudocode for lists on the exam reference sheet to implement an algorithm. So what will we learn? For list operations, you will be able to write expressions that use list indexing and list procedures. And for algorithms involving elements of a list, be able to write iteration statements to traverse a list. Some things we want you to know is the exam reference sheet provides basic operations on the list that we will look at. List procedures are implemented in accordance with the syntax rules of the programming language. So your own language that you've learned in class will have its own set of list procedures with its own syntax. Traversing a list can be a complete traversal where we hit every element in the list, or partial where we only look at a portion of the elements. Iteration statements can be used to traverse a list. The exam reference sheet provides a pseudocode for loops. Again, we'll look at that in a moment. And it does help if you have a knowledge of existing algorithms that use iteration, which can help in constructing new algorithms. For lists, some common algorithms are determining a minimum or maximum value or computing a sum or average of the numbers in a list. So in our exam reference sheet, we have some different things here. Let's take a look. If my list is called a list, in text form, a list bracket I, if I have I in square brackets, that is accessing the element at index I of a list. In block form, the I will be in a rectangular square. I can also access the element at index I and store it in a variable, assign it to the variable X. So in these two versions, the element at index I of a list is being stored or assigned to variable X. I can also do the opposite. I can take a value from a variable and assign it to an element at index I of the list. Notice our text and block do not look that different, but we do see some slight variations. Another thing I can do with lists is take the element at one index, index j here, and assign it to the element at index I. So these look similar. If you notice the text has square brackets, the block has more like a rectangular square around the index. Now, some interesting procedures we have. Insert allows us to insert a value into a list at index I. Append allows us to add a value to the end of a list. And remove allows us to take whatever element is at index I of a list and remove it from the list. Another procedure we have is length. Length of a list will give us how many elements are currently in the list. And we also have some pseudocode for traversing the list. For each item in a list will allow us to access every single element in our list. Let's look at an example. We want to find the minimum value in a list. So we can create or access the list. Let's look at some ideas of what we need to do before we try to write this. We'll need to make or create a variable to hold the minimum and set it to some type of potential minimum value. We're going to need to traverse or loop through the list. And as we do that, check each element to see if it is less than the minimum variable. If the element is less than the minimum variable, we need to update the minimum. And after all elements of the list have been checked, display the minimum value. So what does that look like in terms of actual code? So somehow you need to have accessed or created a list. I just created a list with some numbers in it. I set a variable called min. I assigned it the first element of the list, nums1. So at this point, min is 65. Now I'm going to traverse through the list for each score in nums. So score is the individual element. If that element is less than min, I want to assign it to min. And then at the end, I want to display the min. So when I start this program out, min is 65. I'm going to access the score in min. So score now is also 65. It won't have to update anything. I'm going to access the next score, 89. 89 is a lot less than min, so we're not going to update it. I access the next score, 92. 92 is not less than 65, so I will not update it. I will access the next score, 35. 35 is less than min, so now my min is 35. I still have more scores to access. 84, not less than min. 78, not less than min. 28 is less than min. So I'm going to need to update the value of min to 28. One more score to check, 75, it's not less than min. So I don't have to update it. I've checked every score in nums. So I'm going to display my min, which ended up being 28. Now, how about if you try writing some code? I want you to find the sum of even numbers in a list. You're going to use that pseudo-code from the exam reference sheet. Pause the video and see if you can figure this one out. Okay, I hope you paused and wrote out some ideas. Let's look at what the code should look like. Well, I made up a list for nums to get us going and so that we can use it to test our code. I assigned the value of 0 to sum since right now I haven't added anything together. I'm going to go through every score in nums, so I'm going to use this loop, this traversal for each score in nums again. If score mod 2 equals 0, this is checking to see if my individual score, if the element mod 2 equals 0, in other words, is the remainder when I divide by 2, 0. What that really is doing is checking if I have an even number. If it is, I'll add that score to my sum. When the loop is over, I'll display my final sum. So let's trace through this. Sum starts at 0, and I'm going to go through each score. Score is 5. 5 mod 2 is not 0, so I will not update sum. I go to 3. 3 mod 0, 3 mod 2 does not equal 0, so I'm not going to change my sum. Score is now 8. 8 mod 2 is 0. 8 is even, so my 8 is added to sum, and my sum is now 8. My next score is 4. 4 is even, so I'm going to add it to my sum. My next score is 7. That's not even. 2 is even, so I'll add it to my sum. 1 is not, so nothing happens. 10 is even, so I'll add it to my sum. And at the end, I'll display it. So hopefully at the end of this now, you'll have a better idea of how to write expressions that use list indexing and procedures. And for algorithms involving elements of a list, write iteration statements to traverse the list. The exam reference sheet provides operations on lists. In a programming language, you're going to have your own syntax rules to use. You want to be able to traverse a list either completely or partially, and iteration statements can be used to traverse a list. The exam reference sheet does provide pseudocode for this. And some basic algorithms we might want to do are minimum or maximum, sum or average. Don't forget to look at your reference sheet. Thank you for watching this video. I hope you'll come back and watch some more. In the meantime, go out and have some fun with CS.